So, hey everybody, this is Avneet from Checkpoint, Inlay Portfolio Manager. So we are here today in Euroshop Düsseldorf in 2026. This is amazing. The energy here is fantastic, and we didn't want to miss it out. So today we are going to talk with a special guest because I am from that part. It's Inlay. So we have Kurt from NXP. Hi, Kurt.
Hi.
Thank you very much for joining us. So today the plan is, well, Checkpoint is known as a vertically integrated partner. We are not only doing inlays, we are doing also the manufacturing of the labels, hardware, software, and but today we are going to talk about what's my favorite thing and what's my specialty. It's inlays, and as I always say, the soul of the inlay is the chip. So here we are with Kurt. Tell us about us. Tell us about you. Sorry.
Okay, so I'm Kurt Bischoff. I'm doing the marketing for our UCODE chip product line, RFID chips. Yeah, at NXP, we always have a booth here, and we basically, it's a really exciting time for us now because we just launched our new chip UCODE X.
That's the talk of the show.
We have made the public launch at NRF, and there's already a big demand for that chip, and already a lot of inlays from Oberst are from Checkpoint are open certified already. So it's very exciting time for us.
Yeah. Let's talk. I think that's the talk of the show. We want to know about UCODE X, and we want to present to our retailers and customers what's going on with UCODE X. What's new?
There were several design targets, and we really made a big step. So it also took a while to develop a chip. So we went to a new technology node that allowed us to make two things. The chip much smaller. Yeah, it's now less than a tenth of a square millimeter. If you can imagine that, you can almost not see the chip. That was one part, and the other part was to reduce the power consumption of the chip tremendously, and that was also enabled through that new technology node.
Hey, that's nice. So I remember, let's say 3 Euroshops ago, jeans and clothes were our goal. Okay, so we were doing clothes. 90% accuracy was the goal. And now everything has changed. The retailers are asking us to tag cosmetics, logistics, DC boxes, pallets, even metal and liquids. And also it's not nice to have. It's a baseline that we need to have 99% accuracy or more, of course. So what is giving UCODE X on this part?
Yeah, 99% accuracy and more. So people just demand that, right?
Yeah.
You have to have it. The important part is when you have those difficult to tag items, they contain liquids, might contain some metal parts on the packaging. It reduces the power that comes to the chip and to the label. And this power is transmitted by the reader device. So they take away some of that power that the reader submits. So because of that, the chip and the label have to work with less power consumed. So to bring the power consumption down, it's a key ingredients to still have enough reading range and to have this high accuracy and when you do your inventory takes. So it's all about the power consumption, which is called in the RFID world the sensitivity of the chip.
Yeah.
And we are now down to close to only 2 microwatt. So not milliwatt, but microwatt, right? And that's really low power. Yeah?
Well, we are seeing it in our inlays. When we design, for example, our Vortex, it's already a small chip, but the performance boosted a lot thanks to the chip. So that gives us also the opportunity to reduce a little bit our size of the inlay itself, right? I want to ask you, when you increase the read power or the sensitivity, are you reducing the encoding speed or the encoding power for the reader? Because now they want to read and encode in a higher speed, right? So are we sacrificing on both?
Oh, not at all. Actually, it's always important to have the read and write sensitivity not too much away from each other, right? Okay. So if we talk in sensitivity terms, our read sensitivity is minus 26.2, and the write sensitivity also had to improve because the distance between the two should not be too much. So it's now minus 23. No, it even improved, right? The write sensitivity also had to improve. So both. And you do that in a way that you develop a new memory module that consumes less power, right? And then you can also write at with lower sensitivity. and also the write speed is also improving here. We are also leading on the write speed. That helps for the encoding part.
Yes, for sure. So that's the thing. The body and the brain, I always say, right? You are the brain for our body. You are improving. So when we do the body and the brain improvement, and we can reduce. Correct me if I'm wrong, but we can reduce the inlay size, and also the chip size is reducing. So we are improving in the green stuff, right?
Oh, absolutely.
We are sustainable. We have less consumption of aluminium, less consumption of PET. That means more speed of encoding. That means more speed, more units per minute, let's say. So we can deliver faster and greener.
Yeah, absolutely. The CO2 footprint goes down, right? Smaller antenna sizes, edged antenna, it's not really a clean thing to do. The smaller the antenna, the better, right? And the other part is, of course, the production of the chip, which come on a wafer, which is kind of the size of a pizza. We have now 680,000 on one wafer. So you take two of them, you have more than 1 million. Of course, that also improves the CO2 footprint big time, actually. Big time.
Yeah, well, silicon is one of the main games, right?
To play, absolutely.
Okay, very good, very good. Next big shift is going on with the DPP.
Oh, DPP.
The DPP is well, it's not a nice to have. We are seeing that it's a legal requirement now. And recycles, retailers, customers, everybody's talking about this, and everybody's a little bit worried, to be honest, because now they just do not need to have model size and color when we do it in the EPC recording, and that's it, or the user memory. Now we need to know how is it produced, when it is produced, what is the composition of the product, and then keep this information for a longer time than it was to be expected. So memory is playing a big part on this. How do you manage this part in UCODE X?
Yeah. So digital product passport, right? So, and the retail is a big task for the retailers. They have to collect much more data than before. It's not yet legally mandatory, but the plan is for textile 2027. So that's just around the corner.
Yeah.
Some retailers already prepare a lot, right? Collecting those data and even trying to use them already. So that's a good part. Yeah. There's two ways to do it. Of course, you could, the chip could just point to a server web space, and there's all this big data, right? But some data you want to have also with fast access. And that's what we did on UCODE X. We allow longer EPC sizes up to 208 bit, where you can store some of those data also offline to make basically what we call the edge more intelligent, right? The edge, and we talk a lot about edge processing in our company, and RFID is the edge of the edge, the ultimate data collector. So we allow now to have some data offline, like CO2 footprint, origin, immediate supplier ID, those kind of things. So you have the space to store not all, but a little bit more offline on the chip, and that means fast access. That's the advantage.
Okay, but so correct me if I'm wrong. We are talking about more memory on your chips and modelable, let's say.
Yeah, also flexible. Yeah,
flexible. So thank you.
Flexibility. So it's always the same chip, but our customers, partners like you, Checkpoint, you can configure the chip as you need it. Right. So it comes out default was 128 bit, but you can extend the EPC size to 208 bit. You can also take a portion of it and make it a user memory, 32 bit. So it's very flexible. Yeah. An important part is always the same ordering code, always the same stock keeping unit for you. It makes it simple, and you can configure the chip as you need it.
Yeah. Well, I was, when you were talking, I was thinking also another projects that we have that everybody's looking on the meat, that we need to have the microwave safe, and that could be a really great option for us, because we can modify and flexibility on the EPC and the user memory. So that's great. That's
right. On the food side, yeah, absolutely. You can store more data there. So not just the product number, but expiration date, and even more lot number. Whatever is important on the food side, you can already store on the chip, right? So,
let me get it clear, because this is very interesting for me. The memory is flexible, is much bigger, and normally, and you just have one single model, let's say,
Right.
UCODE X,
Right.
right? So that means in the past, the more memory, the more expensive. What's happening now? It will change the market. For this,
Yeah, I already
right?
mentioned the chip is
Yeah,
very
yeah.
small. No, how we do it, we didn't add a lot of, and it's still only 208-bit EPC
Yeah.
size, right? If we talk bits, not kilobits
of
and not
course.
megabits, right? It's still a small memory actually,
Okay.
but RFID works like that. Now, what we do is we had the design target to make the chip as small as possible, so therefore we allowed a little bit to swap the memory to trade, right? You can trade the kill password and the access password to get more EPC size, right? We didn't want to add memory because the chip should be small. It's also a cost target and also a sustainability target that we have here.
Okay, so I think we have a clear view of what's going on with UCODE X. For closing, I just wanted to ask you because I see that the retailers, some new retailers are overwhelmed with all this information that we are giving because we have a lot of information. So what's the tip that you want to give for the new retailer to start with RFID?
That's a difficult question. I would say, like we said at the beginning, right? Don't be afraid. There was a term said, get wet, meaning make a pilot, make a one-store pilot, try things out, and there are established companies available who can help you, like Checkpoint is here. Take their help. They know they have done this before. They know what's coming. The other thing I want to give a tip, it's also in our DNA at NXP, we design the chip along standards. So we comply to the GS1 standard. That's really important for us. UCODE X is Gen 2 V2 standard of GS1. We do that and we will continue doing that because that enables for the end user choices, multi-sourcing, which they want, supply safety. So we are fully on that path here.
That's great. Thank you for the note. Thank you, Kurt, for joining us. That was amazing. I was super excited to have this small interview podcast with you. For the guys who are seeing us, thank you very much for joining. If you want more information about UCODE X or Checkpoint, please contact us, join us, visit us, whatever you want to do. Here we are.
It's been a pleasure. Thank you very much.